of mountains that includes the Grand Teton Range in Wyoming. Studies of the rocks in these old ranges reveal that the face of the Earth has changed dramatically over time. This is key evidence in support of geology's most important theory, plate tectonics. Plate tectonics theory holds that the Earth's crust is broken into huge slabs called plates. The face of the Earth changes because the plates float like rafts on semi-molten rocks below. The force that moves the plates is heat, which emanates from the very heart of the Earth.
Ultimately, the energy that goes into driving the plates around is derived from the interior of the Earth, and it's just a result of the radioactive decay of the initial elements that were involved in the formation of the mass that became the Earth.
Okay, there's the ruby. I'm going to take a look.
To understand how heat drives the plates, scientists simulate the extreme conditions that exist at the center of the Earth, where temperatures reach 7,000 degrees Fahrenheit.
Okay, where's the other connector for this?
They achieve these conditions with the help of tiny bits of diamond.
We can recreate conditions of the Earth's core by using a diamond anvil cell. We can actually squeeze materials between the tips of two diamond anvils, and we can achieve pressures on the order of 3 or 4 million times the pressure at the Earth's surface. We can also achieve high temperatures in the diamond anvil cell by heating with an infrared laser.
Okay, great. Okay, so you want to turn the laser on? Sure.
Scientists have learned that intense heat from the Earth's core and mantle rises up toward the crust. This causes the mantle to circulate along the bottom of the crust. It is this circulation that moves continents around and profoundly changes their shape and size. Heat circulating deep in the Earth can cause the crust to pull apart, or rift. In North America, a rift dissects the homeland of the native Pueblo people in New Mexico. The Pueblo people have lived in the Rio Grande Rift Zone for thousands of years. They have retained ancient traditions, and many still live in communities called pueblos. The Rio Grande Rift is named after the great Rio Grande River, which cuts a deep gorge down the middle of the rift zone. The river follows a broad valley in the rift, which is flanked on both sides by lofty mountain ranges. This topography is common in rift zones. As the Earth's crust pulls apart, it stretches and becomes thinner. Magma swells up from the mantle below, causing the crust to bulge upward and break apart. Broken crustal blocks rise, fall, and tilt sideways, creating valleys and mountains at the surface. When the crust pulls apart for millions of years, valleys and ranges stretch to the horizon. This is the case in the Basin and Range province of North America. After spreading apart for 17 million years, sections of the Basin and Range have grown wider by 100%. The Basin and Range spans dry desert country, but the spreading, bulging crust has been warped up so high that it invites snow during the winter. Most valleys in the Basin and Range province are enclosed by mountains. Rain and melted snow drain into these closed basins and form lakes, like Mono Lake in California. On the shores of Mono Lake stand odd rock formations called tufa towers. Tufas are made of calcium deposited by underwater springs. The towers were once submerged, but siphoning of lake water for human use has left the tufas high and dry. The presence of calcium-rich springs reveals another feature of crustal spreading, volcanic activity.
When there's rifting, there's typically a break in the crust. The crust itself is broken apart, and prior to breaking apart, it stretches and thins. And so as molten materials make their way up, it's very easy for them to get through the crust. And as they come through the crust, we see them as volcanoes.
In the past, mammoth volcanic eruptions have blanketed the rift zones of North America with thick layers of lava and ash, now hardened to colorful rock. Volcanic rock was a building material for the ancient Pueblo people of the Rio Grande Rift. In some places, cliffs of volcanic rock form the back wall of dwellings. A volcanic rock called tuff was soft enough that cave dwellers could carve into it with simple hand tools. If crustal spreading persists, it can split a continent in half. Ocean waters move in. This happened in Africa, where the famous African rift opened a gap between the continent and Saudi Arabia. The Red Sea was born. In North America, the Rio Grande Rift and Basin and Range Province may or may not progress to the ocean stage. But the crust is spreading apart today, creating a lively, rugged landscape. One of the liveliest places associated with crustal spreading lies just north of the Basin and Range Province at a place called Yellowstone. Yellowstone National Park is world famous for its bizarre volcanic landscape. There are no active volcanoes here today, but past eruptions are among the largest ever produced on Earth. Below Yellowstone, a column of hot magma rises from the mantle to within a few miles of the Earth's surface. The subterranean magma fuels hundreds of geysers in the park. Thousands of other thermal features are found here. In fact, Yellowstone Park contains the greatest concentration of magma-driven features in the world. At any time, magma may once again rise to the surface at Yellowstone. Geysers will be replaced by volcanoes in mammoth eruptions of lava and ash. Past eruptions at Yellowstone have thickened the Earth's crust with thousands of feet of volcanic ash and lava. The entire depth of the colorful Yellowstone River Canyon is made of volcanic rocks. Where lava flows pile up in the canyon, the river cascades hundreds of feet over waterfalls. Yellowstone dramatically shows how volcanism thickens the continental crust at the surface. Recently, geologists have discovered that volcanism also thickens the crust in a different way, from the bottom down. This is the Cima volcanic field, a part of the Basin and Range Province in California's Mojave Desert. Here, geologists comb the flanks of Cima's dormant volcanoes, looking for special rocks called xenoliths.
Very special localities like the Sima volcanic field have a great abundance